Using Coulomb's law, we can find the force acting on a given charge because of other charges in the situation, such as this example. Before we do this, let's look at the theory. If we have two charges, Q1 and Q2, separated by r meters, Coulomb's law says that the force acting on these charges would be directly proportional to the product of their magnitude and inversely proportional to the square of the distance between them. The full equation is force equals K times Q1 Q2 over r square, where K is Coulomb's constant. It has a value of 9 times 10 raised to 9 newtons meter square per Coulomb square. For example, first and second two charges, let's say they are both positive. The charge on A is positive, charge on B is positive as well, and we know that like charges repel, so they will try to get away from each other. A will try to go away from B, so it will not go towards B, it will go in the opposite direction like this. That means the force on A because of charge B is to the left. To find the magnitude of that force, you will use this equation. K is constant, Q1 would be the charge of A, Q2 would be the charge of B, R would be the distance between them. For B, it's going to be repelled by A as well, so it will not go towards A, it will go away from A. So the direction of the force on B would be to the right. If you have one positive, one negative charge, let's call it P and Q, they will attract each other, so P will try to go towards the negative charge. The force on P would be towards the right. Q is negative, it will try to go towards the positive charge, to the left. So the force on charge Q would be acting to the left. Now let's look at this example. We have three charges, we know their distances, we know their magnitudes, and we are trying to find the net force on C, on the third charge, on this charge. We know the formula, and we see that we have three different charges. The force on the charge C will be because of A and because of charge B as well. We will calculate them one at a time. Force on C because of A would be K times Q of A, Q of C. We take both the charges divided by the distance between A and C square. That would be 9 times 10 raised to 9 times QA. The charge of A is 4 times 10 raised to minus 6, and QC, which is 6.4 10 raised to minus 6 over RAC, the distance between A and C. The distance between A and C would be 0.6 plus 0.4, which is 1 meter, so 1 square. When you use your calculator, you get 0.2304 newtons. Now this force is acting on C. A is positive, C is positive as well, so they will try to go away from each other. So the force on C would be away from A. That means acting to the right. That's the direction of force on C because of A. So we can say that we have this force acting in the right direction. For the force on C because of B, we have K times Q of B, Q of C over R B C square. K is 9 times 10 raised to 9. QB, now notice something here. B is a negative charge, but in the formula we only write the magnitude. So just write 2.5, not negative 2.5. and then QC is 6.4. RBC, the distance between B and C is 0.4, so we do 0.4 whole square. When you solve, you get 0.09 newtons. Now this one, B is a negative charge, C is a positive charge. They will attract each other, so C will try to go towards B because of the force of attraction, so the force would be to the left. We have 0.09 Newton acting towards the left direction. And net force on C would be force on C because of A plus force on C because of B. Add them together, we have 0.2304 plus, since this is acting to the left, this will be in the opposite direction, so you subtract this value 0.09 and you get 0.1409 newtons, and that is acting to the right. That's how you calculate force on a given charge because of the other charges present. If you understand this, try solving this problem. You have 3 charges, you know the distance, and you are trying to find the magnitude and direction of the force on each of the charges. So just like this previous example, I only found the charge on C, but in your case you are finding the charge on C, the charge on B, and the charge on A as well. Do one at a time and write your answers in the comment below.